Today we are factoring polynomials by quadratic form. So get your date, page number, learning target, title, all that fun stuff. And then make sure you get all this stuff down. And I want you to try to factor these. So we did these, we've been doing these for a couple months. I want you to practice factoring them. Not solving, just factor and stop. Okay, so as you saw, when you did this one, you should have gotten x plus 4, x minus 4. And there were two different ways you could have gone about that we've talked about in class. The fastest way is you could have noticed that this was a difference of two perfect squares. And it's the square root of the first plus or minus the square root of the second. So square root of x squared is x, square root of 16 is 4. Another way you could have thought about it is said, well, there's a 0x here. So I need to find what multiplies to give me negative 16 and adds to give me 0, which is 4, and negative 4. So then you end up with x plus 4, x minus 4. This other one, there's nothing in front of x squared, so I can go straight into the factor x. I need to find what multiplies to give me negative 40 and adds to give me negative 6. And those two numbers should have been negative 10 and positive 4. And I get x minus 10, x plus 4. And because we're not solving, you're going to just stop here. I'm going to rewrite that so it looks nicer, but you're just going to stop. All you're doing is factoring still. Okay, we haven't solved anything yet with these polynomials, so we're just factoring. So you've just broken it down. So that's how you did it with quadratics. Notice that's because x times x is x squared. X times x is x squared. So now that we have polynomials of a higher degree, it's the same idea. Okay, remember your difference of squares, however you want to do it. If you just memorize the difference of squares, if this is a perfect square, this is a perfect square, it's plus or minus the square root of the front one. So the square root of x to the fourth is actually x squared. So the front number is here. And then the square root of 16, it's 4. Okay. So that's one way to think about it. Another way was the negative 16 on top, the 0 on the bottom, 4, and negative 4. And again, these have to be x squareds because x squared times x squared is the only way to get to an x to the fourth. Okay, now because that is an x to the fourth, and last time that was just a plain old x, I couldn't do anything else to this. So this wasn't going to be a difference of squares. It can't be factored any further. But now that I've done this and it's got an exponent on it still, I need to factor it still if I can. Remember, if it's a perfect square and it's a difference, only if it's subtraction can you do that plus or minus. So because this is minus, and these are both perfect squares again, I can do it again. So the square root of the front is x, the square root of the second is 2, so I get x plus 2, x minus 2. Now this one I can't factor any further. And I'll show you why. Had you pulled it up here and said, well, there's a 0x in the middle, what multiplies to give you 4 and adds to give you 0? Nothing. There's nothing that will multiply to give me positive 4 and add to give me 0. This one did work because it was what multiplies to give you negative 4 and adds to give you 0. So 2 and negative 2, which is how I ended up with this pink equation right here. Okay, let's look at the next example. This one. Oops, this one. So, again, there's nothing in front of my leading coefficient, so I can go ahead into the factor x. What multiplies to give me negative 40, adds to give me negative 6, and that was negative 10 and positive 4. But again, instead of a plain x, I have to have an x squared minus 10 and an x squared plus 4. That does not look nice. X squared minus 10, x squared plus 4. My pen is jumping around for whatever reason. So again, those have to be x squared because when I went to go multiply it back through, I should get an x to the fourth. So I'm going to check and see, can I factor this any further? Well, that's not a perfect square. That is a difference, and that is a perfect square, but that one's not. There's nothing that you could multiply to get negative 10 and add to get 0. So that won't factor any further. That one's done. And then this one, that's a plus. Even though these are both perfect squares, it's not a difference of squares, so it doesn't factor any further either, because there's nothing that will multiply to give you positive 4 and add to give you 0. So this one's done. But basically, that's the idea. When you factor something to the fourth degree, you would take out a GCF if you can. You would slide and divide just like you would, but instead of being just a plain x here, if this is an x to the fourth, those would be x squareds.